In this scene, Elliot wipes the records, but notice something. He doesn't use this command, because that's not how file deletion actually works at the file system level. When you delete a file, the operating system does not erase the data from the disk. Instead, it only removes the file's metadata. The file name is removed from the directory structure, and the file system forgets where the file was stored. The important part is this: the actual data blocks on the disk remain unchanged. The bits are still there. What the file system does is simply mark that space as free, meaning it can be reused later. Until new data overwrites those blocks, the original file still exists on the disk. Let me show you how it is done. First, I'll create a file with some data. Now the file exists on disk. Now I'll try to recover the deleted file. Using a recovery tool, we can scan the disk for recently deleted files. This works because delete doesn't remove data. It only removes references. Now let's do it properly. This time, I'll overwrite the file before deleting it. What shred does is overwrite the file's data blocks multiple times with random data and zeros, and then removes the file reference. Now the original bits are gone. Even if we scan the disk again, there's nothing meaningful left to recover. In the next scene we are discussing, Elliot hides the encryption key inside his childhood photo. This is a classic technique called steganography. Digital images are made of pixels, and each pixel is stored as binary data. By slightly modifying the least significant bits of those pixels, data can be embedded without visibly changing the image. This does not change the appearance of the image, but it is enough to hide data inside it. Let's say we have an encryption key stored in a file. Now we hide this key inside an image using a steganography tool. The tool injects the key data into the image file. The image still opens normally, but now it contains hidden information. Even if someone opens this image, they won't see the key directly, because there is no readable text. To extract it, you need the same steganography tool that was used to hide it. Using the tool, the image is scanned for embedded data. Then it will ask for the password. Once extracted, the encryption key becomes available again and can be used normally. That's all for today's video. I hope you enjoyed it and learned something new. If you found this useful, make sure to like the video and subscribe for more content like this. I'll see you in the next one.